Dear students, today we are going to discuss operating systems. My name is Parthasarathi Mukhopadhyay. I am teaching in the Department of Library and Information Science, University of Kolkata. Definitely, you people have utilized computer system, maybe desktop, maybe laptop, and every time you are opening your system, you are encountering the first software, that is operating system. In fact, this particular system software, operating system, first loads inside the RAM and then it remains on the RAM so that other functions can be performed smoothly inside your computer system. You can say that an operating system is a fundamental component of a computer system. And this is considered as a system software. You all know that there are two kinds of software, particularly broad groups. These are, one is system software, another is application software. So system software may be of again different kinds, but operating system is the major one. And as a library professional, whatever software you are using for managing your libraries, maybe library management software, what we call ILS, integrated library system, your different kind of office, so all require operating system. In fact, every application software is designed to talk to the system software. System software actually working as a resource manager of the entire computer system, and their operating system is basically the key parameter. So let us now discuss that what we are going to talk today. Libraries are using lots of software, office automation, content management system, ILS, integrated library system, digital library system. So we have a huge software ecosystem. As a library professionals, you need to know 10 plus, application software. But as I said, that each and every this particular application software is designed to talk to the desired operating system. Some software, for example, are operating only on MS-DOS operating system. Some software can be executed only in Windows. Similarly, some software can be only in any Linux-based operating system. So it is fundamental one that we will study. And then before beginning or before making a quantum jump inside operating system, we need to understand that what is the role played by a system software, particularly operating system, and what are the other system software available inside a computer system. And then we'll be going to discuss different types of operating system, how we can categorize, what are the domains, and there are distinction between the closed source commercial product like Windows operating system and open source Linux based product, and what is Unix, what is Linux, and these are we are going to discuss. And finally we will be landed to a very important decision, that as a library professional, what particular Linux distribution you are going to implement in your library and what should be the criteria for that. So let us now, begin this one, that what is the software ecosystem in a particular library. So here in this particular screen, you can, understand that I have given a broad picture of different, component of the library software ecosystem. And you can see from the top, it starts from system software and application software. Application softwares are of different types. As I said, you are managing your library homepage, library website, you are using a CMS like WordPress or Drupal or Joomla. Similarly, you are managing the institutional digital library for your institute. So there you are using maybe Printstore, maybe IPprint. Then comes the core component of this ecosystem that is called library automation software or integrated library system. So in this way, you can see we can have digital library system, DLS, or LSP, library service platform, which integrates all kind of application software, retrieval interfaces of your library OPAC, your digital library system into a single box search system. So that is basically the library discovery system, which actually later builds LSP or library service platform. So here you can see your library automation software. For example, if we take the core part of this ecosystem, your library automation software performs a lot of jobs like housekeeping operation, acquisition, cataloging, or retrieval, like your library OPAC, report generation, statistical, data extraction, MIS, management information system, a lot of job. But here you can see every time it is actually talking to this system software. Every ILS is designed to talk to this system software, generally an operating system, either it can be Windows or it can be Linux-based operating system, and then only your system works. So the entire ecosystem, in the entire ecosystem of the library software, operating system works as a key parameter, as a key component. So now if we go to the next that here we came to know about the system software and application software. So what's actually the difference between these two? Here in the screen, you can see the differences in a tabular form. So basic difference, what I'm not repeating the screen, what it is written, what I'm trying to give you the essence of these differences. A system software is meant for managing the computer system. It is responsible for the overall management of the computer system. Whereas an application software is meant for a specific task. For example, you are writing a letter. You are using MS Word. You are designing a database of employees. You are using spreadsheet or library automation. You are using library automation software or ILS. So these are all meant for specific job like database management system, multimedia, video recording, and many more. So these are domain specific. Whereas computer system software are more fundamental, and these are mandatory. You must have an operating system to start a computer system. But whereas in case of application software, these are optional. You don't need to write letter. You don't install MS Word. You don't need library automation in that particular machine. Don't install it. So these are all optional on the basis of requirement you are going to install. And system software like operating system is much more complex, whereas application software is is not that complex. But every software development is involves some kind of complexity. But if you compare the degree of complexity between these two, your operating system is much more complex. And that's why if you see the history of computing for the last 50 years, right from 1970 to till date, there we are having only 5 6 major operating systems, whereas application software there are millions, even billions of application softwares are available. You name it, we have it in different domains. So this is basically the differences. And operating system, as I already told you, is a major kind of system software. Now if we move further, as a system software, what an operating system performs? An operating system basically performs different kind of fundamental job like managing hardware, optimization of the performance, enabling interoperability, replicating system, management of different kind of firmware, and so on. So as a whole, the family of system software includes many other components apart from the operating system. Let us see what are these components. So here you can see in this particular screen that uh, mm, definitely operating system is the most important one if we start from there. But apart from operating system, we need to have different kind of utility program like your antivirus, like your file management system. Then we need to have different kind of device drivers, like you are installing a printer, you need printer drivers. You are installing a particular input devices like a scanner or something like that, you need driver for that particular device. So these are basically the device drivers are also considered as system software. Then comes the firmware like BIOS. You always change the fundamental things like, say, for example, you are enabling a virtual interface of your computer system. So there you need to change the BIOS in doing so, basic input output system of a computer system. So this we call firmware. And finally, there is emulator and simulator. Emulator means it basically camouflage a particular computer so that it can behave something different. Let me give you one example. Suppose from your laptop or from your mobile you are using a computer server. A computer server is a mainframe computer. It's the hardware architecture, the operating systems all are different. So here the emulator is actually changing your mobile phone in such a manner so that the server understands the request or response are coming from a server or equivalent computer. Similarly, when it is receiving response from server to your mobile phone, then server is camouflaged in that way that it basically your mobile phone is understanding that it is coming from a similar kind of device. So this kind of emulation is going on and on in the network, and emulators are a very fundamental component of the entire system software family. And simulator generally we use to simulate different kind of situation like your um, designing of shoes, designing of cars. Then in case of science, you are trying to measure the blasting power of a nuclear device. So every time you are not going to blast a nuclear bomb, you conduct that experiment once and adding different kind of parameters. You are simulating that if I increase the power, if I increase in place of one TNT bomb, if we place a two TNT bomb, then what will be the devastating power of that particular bomb? So we simulate that kind of processes. Weather forecasting use a lot of this kind of simulators. But our target is here operating system. We are not going to details with the other system software. We are targeting operating system because this particular video tutorial is meant for that. So now if we come to this operating system, as operating system is a kind of system software that manages hardware resources, provides a user interface, and enables the execution of application programs to ensure efficient and secure computer operation. So on the top of this definition, if we try to extract the fundamental components of an operating system, you can see it's a kind of system software. It provides user interface. That user interface can be a CUI based interface or a GUI based interface. It offers security and stability to the system. It works as a resource manager. Everything attached with the computer is a resource. Hardware is resource, software is resource, humanware. As a user, you are also a resource of computer system. So all are managed by the operating system of that particular computer, and it is also responsible for execution of different kind of application software. As I already told you that application softwares are written to talk to operating system. For example, I want to print a letter which I have typed in MS Word. So the moment I click print, that print command, that MS Word software has no access to the printer. Printer is a resource, only operating system has full control of it. So your application software like MS Word sending this request to the operating system. Operating system then takes the task and carries out the printing function. So every time you are saving a file, you are printing a file, you are relocating a file, you are mainly going through the operating system. Until and unless you go through the operating system, the hardware of the computer is not available, not accessible to any application software. So storing, relocating, printing, file sending, all depends on operating system. So that is the nature of operating system. Now, if we come to the next slide, here you can see that we talked about this application, this user interface of an operating system. So operating system user interface like a Linux based operating system. Here what I am showing you this Ubuntu operating system. Here I can access my Ubuntu operating system either through command prompt, that is called CUI, character user interface, or through graphical user interface. In the first upper part of the slide, you can see that how I am starting a particular program in an Ubuntu software, Ubuntu operating system by using a set of commands. And there I am showing you in the latter part of the slide, or the bottom part of the slide. Here I am showing you how graphically I can navigate from home to desktop, then to a particular video folder, then a particular file, click it to open it. So this is called GUI based access. So this is visual cell, and that is the bash cell. So bash cell is responsible for your commands, and the power of an operating system generally comes through its command, particularly in a Linux or Unix like operating system, like Linux based operating system, Ubuntu, Debian, Fedora. Their major power, the beauty of that particular operating system, you can fully exploit if you know the command. In graphical user interface, that is generally meant for the novice user, first time user. But when your computer skill increases, gradually you will be moving towards the command based interaction with your operating system. So this is basically the user interface, how you can interact with an operating system. Now you can see that what are the operating system performs many jobs inside your system, and many jobs at the same time parallelly. But if you go through that the major roles of an operating system of any kind, then there are five only. So computer operating system works as a resource manager. It is basically the manager of your computer system. It works as a resource manager. What do we mean by resources? As I already said, that everything attached with the computer is a resource. Your CPU, your RAM, your storage, your user, your software, application software, of course, all are resources, and these all are managed, like install, store, execute by an operating system. Then the second important role of an operating system is as a processor manager. As a processor manager, the major role of a computer to sequence different kind of operation, when a big job comes, how to divide that big jobs and utilize different cores or different number of CPUs to perform that job simultaneously. That we technically call parallel processing. This is one of the most important job of an operating system, sequencing of operation and performing big job through n number of CPUs. So this parallel processing, multitasking, multi-user management all comes under this processor manager. Then comes the device manager. As a computer is full of devices like your hardware, your storage, your printer, that is output devices, input devices, all are managed by the operating system, because only operating system can access that. No application software can touch that. Then it also acts as a memory manager, because the most costly component of any computer system is its processing unit, CPU or GPU. Then the second next important component or costly component is its RAM. So how to utilize that RAM optimally in a productive way, that is determined by the operating system as a memory manager. And you have definitely noticed, when you are using operating system, you are giving your PIN, your username, your password. If password is wrong, computer operating system don't allow you to enter. So who remembers this? Everything is remembered by the computer operating system as an information manager. So these are the five fundamental jobs of an operating system: as a resource manager, as a processor manager. In processor manager, you please take a note, the most important thing or most important job is parallel processing, multitasking. In case of device management, the most important things, how different device drivers are utilized by the operating system to interact with the input devices, output devices, storage units. Then as a memory manager, it's basically handles the next most costliest equipment of a computer system, that is RAM, optimally, how to use that. It also uses different kind of technologies like virtual memory management, swap management. And as an information manager, it remembers everything: who logs, when he or she logs, how many times he or she spends inside the computer system, how many attempts he or she made during this login period by using wrong password or something like that. Everything is noted Everything is logged, everything is remembered by the operating system as an information manager. So these are the five fundamental roles of an operating system. So as we were discussing that an operating system performs five fundamental jobs. Here you can see a visual interface for that. How operating system is managing the network, different kind of access, remote access kind of thing, processor manager, the device management, user interface management. Like as we have already gone through that particular thing that I demonstrated before you, how you can interact with through the command prompt as well as GUI based or through icons. So these are all managed. User interface capabilities of an operating system of a computer system is managed by the operating system. Then it also responsible for multitasking, parallel processing, multi-user management. That means a serious kind of operating system. I'm not talking about Windows. I'm not talking about DOS. These are not operating system per se. These are operating environments. So operating system like Unix, like Linux, they are all multitasking and multi-user management, because one operating system can handle n number of user, and any user can run n number of jobs. So that kind of complex system, that kind of complex network based dumb terminal based system like Indian railway system, thousands and thousands of dumb terminals are attached with that computer server, and there is only one server which is managing, and only one server means only one operating system is managing all of these things. Then the memory management job of an operating system, memory allocation, segmentation, virtual memory management, file creation. As I said, that file, folder, all are stored inside your computer system, and only operating system knows where a given file is stored, when a given file is ended, and when and the next part of that particular file begins. So when you are opening a particular doc file through your MS Word do not know where this particular file is located. It sends a request to the operating system, maybe Windows operating system, or maybe in case of Open Office, maybe any Linux based operating system. Then that operating system actually locates that file and send that file to the application software, here MS Word or Open Office, and then only you can see it. So every time you are interacting with an application software, at the back end your operating system is working. That is the the structure of entire computer system. It basically revolves around your operating system. So now you see these operating systems can be of different kind. System, a single user based single tasking system like MS-DOS, single user based but multitasking kind of operating system like Windows, or as I said, the most serious kind of operating system which supports multitasking as well as multi-user management like Unix based or Linux based. And every time you can see in the screen that I have given, that operating system can work in CUI or in GUI or in both CUI and GUI. Mostly the GUI based operating system also supports CUI or command prompt. So here let us go for a fundamental categorization of operating system, because this is required for a library science student, how we are categorizing something fundamentally that you are basically learning through your library classification. So let us apply that knowledge to categorize operating system. So here you see I have taken two train of characteristics, whether the operating system is character user based or a graphical user based, whether it is supporting a single user or a multi-user, or whether it is able to support a single task at a time or a multiple tasks at a time. So that is called multitasking. So on the top of this, you see, if we divide the entire structure of this categorization into this way, let us go by the interface type, then single user single tasking, single user multitasking, multi-user multitasking, and each and every cell I have given one example for each of these kind of operating system. Single user single tasking CUI. The best example is MS-DOS. And before MS-DOS, it was PC-DOS. Then CUI, but single user multitasking, all the latter version of OS2, obsolete operating system. And CUI, multi-user multitasking, one example, best example possibly is the Unix. Unix operating system started a history in computer, system. The entire internet, entire network you are accessing, most of them servers are based on Unix operating system or Unix-like operating system. But Unix was character user based. It was not available in GUI format. So later on, if we go through this one, like single user multitasking, but GUI. So almost all Windows operating system, Windows family of operating system, Mac OS, their GUI supports single user but multitasking. But in case of GUI, but multi-user multitasking, we have Windows NT in one of the most important component of the Windows family, Mac OS server, or any Linux-based system. Here, one point you must be, remembering that Linux is not an operating system. Linux is the kernel, and on the top of that kernel, lot of full-fledged operating systems are available. So, if somebody is saying that Linux operating system, so he or she is saying it wrong. Linux is a kernel. On the top of that kernel, different kind of operating systems are coming. Will be coming very soon. Different example of Linux-based operating system. But please remember, Linux is a kernel. It's not a full-fledged operating system. It's a clone of Unix. Unix is not available in the open source domain. You have to buy it. But Linux is available, which is basically the cloning, the Unix architecture, but made available in the public domain as an open source kernel. And people are using that kernel to develop different kind of full-fledged operating system like Ubuntu, like Debian, like Fedora, and so on. So this is basically the categorization. And if we go through the Windows versus Unix like operating system, that which way to go, again, I am not going to repeat and read the differences I have given here. You are having it in the screen. What I am trying to show you the major fundamental differences. First difference is that Windows is an out and out commercial product. You have to buy it. But any Unix like operating system like based on Linux kernel, you are getting it free, the community version. Then you can say if something is available free, then it is better. No, not exactly. What makes Linux better than Windows is the architecture, is the security. Windows operating systems are virus prone, but it is very difficult to infect a Linux operating system through virus because the software architecture, the security works in such a way that virus generally not able to attack a Linux-based operating system or server. So that is another difference. But the most important difference is that behind the Windows, there are only a handful of programmers. How many programmers Microsoft can hire to develop an operating system? 1,000, 2,000, 5,000? Behind Linux, any Linux-based operating system, there are millions of users. And this Linux-based operating system follow open source laws like release early, release often, and consider your users as co-developer. The moment I release it, many eyes makes bugs shallow. They are readily, catched or caught by the users. They report it. On the basis of that report, operating system is rectified, and again the next release comes. So every 6 months, almost every Linux-based operating system provide a release. So the updation is continuous and guaranteed. So these are in case of Windows, you will see almost 10 years gap between two versions of Windows. So in this way, operating system is a very fundamental things, and in technology, 3 years is a long gap. Then don't talk about 10 years. Within that 3 years, many new things happen. So during these 10 years, you are not taking advantages, or you are vulnerable towards different kind of malware attack. So that's why most of the internet service providers servers are switching to Linux operating system, and you can go through these differences obviously. So let us have a brief history of this Linux operating system. It's basically developed by Linus Torvalds as a student project. At that time, he was a second year computer science student. Can you imagine that? So in 1991, he developed that particular project. And the single most important decision taken by Linus Torvalds, which changed the history of computing in the human society, is to make it open source. So anyone can utilize. So 1991 itself, he made it open source. People started exploring it, found it very good as a multi-user operating system, better than Unix even. GUI enabled. That particular thing never came by 1991. It took another 5 6 years to integrate GUI on the top of the Linux kernel, but certainly it happened. So the major features of this Linux ecosystem is that it's a collaborative project. Thousands and millions of users from different countries are attached with it. Free distributions, release is ensured in every 6 months. Stability, security, all is offered and transparent. The entire development process is transparent. You have, as a user, has a right to know why this improvement has happened. So this way it is very transparent. Documentation is very good now, and it's quite flexible. Supports a wide array of hardware. So this is making Linux is possibly the operating system. Not the operating system, the kernel of the operating system, on the top of which different operating system is coming. So now you see it originated in 1991, developed by Linus Torvalds. It's a monolithic kernel like Unix. It's a clone of Unix actually, highly customizable as it is open source. Anyone can play with the source code, change accordingly. They can read, they can write, they can modify. So all fundamental rights as proposed by the open source community is associated with Linux kernel. It's completely secure and stable, open access and completely free. That plays extra role in a country like India. Multi-user and multitasking support is available, and a wide array of hardware is supported, like printer, the storage units, your scanner, every driver is readily available. Now, on the top of Linux kernel, as I said, there are many operating systems. These we technically call Linux distribution or Linux distros. So a Linux distribution or distro is an operating system which is based on the Linux kernel. So it takes the Linux kernel and develop the full-fledged operating system. So there are thousands of such Linux distribution, but you can categorize all these distribution into two broad groups. One is happening under the leadership of the Red Hat. We call it the Red Hat group of Linux. Another is happening under the Debian group of people. So Red Hat use RPM, Red Hat Package Manager, to install, to configure different kind of application software, whereas Debian people use .deb or Debian packages to do that kind of installation and configuration. So in case of Red Hat group, there are Red Hat Enterprise Linux, which you need to buy because those are certified Linux. But a lot of community versions are also available from Red Hat, like Fedora, CentOS, Rocky Linux, and many more. And in case of Debian, generally the actual, the real life computer developer who works in operating system, they like Debian very much. Debian is the blue-eyed boy in the computing industry. And on the top of Debian, there is Debian Core, which is slightly expert friendly, but there are a lot of user friendly, novice friendly operating system based on Debian, like Ubuntu, like Linux Mint, like Mandrake. So all are based on Debian group of distribution. You can have a complete picture of this distribution from this website, distrowatch.com. In real time, it is actually indexing all kind of distribution alphabetically, which are the most popular according to their number of downloads and so on. You can have a complete picture from this website, distrowatch.com. So now, as I said, the most important decision for a librarian is that which way to go, which particular distribution I should prefer. In fact, most of the libraries all over the world are using Ubuntu as an operating system. Why Ubuntu? Because Ubuntu is supported by, I have given the reasons, but apart from that reasons, I am giving you some extra information that Ubuntu is supported by a big companies through their CSR project, corporate social responsibility. And that company is South Africa based company, which is called Canonical Private Limited, the largest diamond prospecting company of the world. They donated a huge sum of money through their CSR to develop, Ubuntu. And that tagline of Ubuntu is that Linux for human beings. And that's a very interesting and thing. And Ubuntu, the very term came from a South African ethical ideology. Ubuntu means a person who is open, who is interactive, who is friendly. So that particular Ubuntu, an ethical ideology of South Africa, is actually taken as the name of this operating system because it is friendly, it is interactive, and it is cooperative. It is supporting every person who wants free computing and a secured and stable computing. So that's why we are using Ubuntu. Ubuntu releases every year twice, in the month of April, in the month of October. And every 2 years, there is an LTS release, long-term support release. So we generally switch from LTS to LTS. Like previous LTS was 22.04. This last is 24.04. 24 means year and 04 means April. And the next LTS will be released in 26.04. In this way, up to 2050, the entire SAM is ensured by Canonical to support development of Ubuntu. That's why people are moving towards it. The other reasons I have given in the slide. So if we want to summarize now that what kind of operating system we need to use in library, that is basically whether it is supporting multi-user, multitasking, supports wide compatibility with the hardware, different kind of network support, ease of use, open source, security, all of these factors comes into play. But definitely you please remember the release cycle is very important for an operating system, because operating system, if it gets corrupt, everything will get corrupted. Your database will be under risk. So do not compromise with operating system which is not secured, which is not stable enough. Then, as a librarian, why should you learn Linux as an operating system? For example, Ubuntu or Debian, like cost effective. You can download and try yourself. You can customize. It's completely secured and supported by a lot of community members. Suppose you are facing some problem, just ask a question in askubuntu.com. We have a very huge user base. Anyone will respond, that I can guarantee from my own experience, that you will be getting response within 15 minutes to solve your problem. So that kind of interactive help is available. And definitely everything is not rosy. When you are switching to a new operating system, mental block is one particular problem. So pros is that your it is customizable, free, troubleshooting is really fun, server management is easy, but there is also a steep learning curve. You have to learn a new operating system. You need to invest a lot of times. Initially, there will be some kind of hiccup, but once you are get through it, then the entire world is yours. And as a library professional, you need to understand Linux, because most of our application softwares are LAMP-based software. And LAN, the L in LAMP stands for Linux operating system, any Linux-based operating system. So you can go through a set of reading references. I have tried to give here a set of open access resources so that you can have an idea of operating system.